Hey everyone, thanks again for joining us here. This is Testing and Monitoring APIs on AWS. Again, my name is Chris Munns. I'm currently Senior Manager and Lead of Developer Advocacy for Serverless at AWS. I've been here at AWS now for just about 8.5 years across a couple different roles. And for most of the last 4 years focused on this space of serverless. And so you'll see myself and my team, we write a lot of the blog posts that you might read about serverless technologies, give a lot of tech talks like this, do live streams, engage in social media, and you'll see us delivering quite a number of talks at the upcoming virtual reInvent that we have this year. We're here to help you, and so always feel free to reach out. I've got some contact information here on the screen, and I will have that here at the end of today as well. So why are we here today? We're going to be talking about this concept of APIs, and obviously this is an important topic for a lot of us who develop, build, and run, operate, secure, architect software these days. This concept around APIs, or application programming interfaces, is really core to how we architect things, again, for a number of different use cases. Many of us, again, are building API-based applications. We're interfacing with API-based applications. And there's a lot of nuance and a lot of things to them that we have to think about. Again, we're talking about an API and about the API layer today. We're going to be focusing primarily on the API gateway. So it's kind of the core of what you see here in this diagram. The thing that sits somewhere between the client and our backend. It could be a web server or a Lambda function or database or data store, a number of other things. And it's responsible for interfacing back out with the request and the response of our application. And so, again, today's focus is really going to be on that API gateway layer, specifically a product that we have here at AWS called Amazon API Gateway. We're going to be talking about this in the context of serverless applications. So this is part of the Serverless Tech Talk series. And when we're talking about serverless, we're typically talking about applications that are built around AWS Lambda. So AWS Lambda is a compute offering represented here in the center of this slide. It supports a number of built-in runtime languages that you see here listed, as well as a thing called the Runtime API, which allows you to bring almost any language to the Lambda environment. And then the event source, which you configure then as a trigger that invokes your Lambda function. Today, we've got well over 100 of these across AWS. They are things like Amazon API Gateway, storage services, database services, development management tools, and so forth. And so as actions come in, as requests to APIs, as events to things like queues and streaming data collection services, as events inside your infrastructure happen, then Lambda can be invoked and executed. It runs your code. That code then does whatever it is that you might have configured it for. So talking databases, data storage, and so forth. Now, we're not going to be spending a whole lot of time talking about Lambda and what it can do or the services behind it. We're really going to be focusing, again, here today on this concept of API Gateway. Now, we are going to have some examples later that are focused around this idea of a serverless web application or serverless web architecture. It looks pretty much like what you see here. So we're going to have our static front end for our web application hosted in another Amazon product called AWS Amplify Console. That is a product that allows you to store static web assets. So HTML, CSS, JavaScript. You can run things like single page apps. You can run cool JavaScript frameworks like React and Vue and Angular and all sorts of stuff inside of Amplify Console. Again, not a hard focus of today, but that's where our front end will be. You can use services like Amazon Cognito to do user management, to handle the authentication to that web app and to your API. That will exist a little bit here today, but again, not something we're going to spend a ton of time on. And then at the bottom here, we have our actual API tier. So we have Amazon API Gateway, fronting a Lambda application that will talk to DynamoDB. And so this really represents the custom business logic that we'll be executing for our application. But again, the main focus today is going to be around Amazon API Gateway, its ability to host and represent our APIs, and then the capabilities that come with it and around it for testing and monitoring. So we're going to talk a little bit about some of these overviews of what Amazon API Gateway is. For those of you who are new to it or maybe haven't seen it in a while, there's a number of things that we'll talk about here about the product. We'll then talk about some of the built-in observability, troubleshooting capabilities that exist inside of API Gateway. And then lastly, we'll talk about monitoring and testing your API functionality and talk about how you can do that on an ongoing basis, how you can troubleshoot all sorts of potential aspects to your API, and try to put this all together to give you some direction to take with your APIs. So let's go. So again, for those of you who are new to the space, Amazon API Gateway, part of the serverless family here at AWS, is a fully managed API Gateway product. That's a space in the industry with a lot of different players in it. But what makes API Gateway really unique, again, this aspect of being serverless, is you're not managing any infrastructure, whether it be virtual, physical, containers, VMs, none of that. It can scale on demand as the load increases for your API. Again, that's completely transparent to you. You don't have to think about it. You pay just what you're using. So you're paying for the API requests and the data that your API Gateway is processing. And it's highly available, fault tolerant, has a number of layers of security built in. Now, we're going to be focusing, again, primarily today on the testing, monitoring, observability side of things. We do have a number of other talks that go more in depth into API security or into building and deploying APIs. And we'll drop some links for you here in the chat so that you can go and follow those when we get a chance. Now, API Gateway is a super robust, I'll say, suite of products. There's technically 3 different types of APIs that we support today, which I'll talk about here in a moment. And API Gateway supports different types of endpoints, supports different types of backends or integrations. It's got integration as well with a number of products that we'll see and we'll talk about here today, such as CloudWatch and X-Ray. It's got the ability for you to cache things. It's really, again, a product that has a number of different ways that you can plug into it from every different angle. First launched a little over 5 years ago now, and something that we've seen customers do things at massive scale, at small scale, all sorts of different workloads. Now, when it comes to how your customers can interface with your API, we support 3 different types of endpoints. So again, think of this as from the outside of your API, connecting to it, where this API is basically made available. One is an edge optimized API. So this is an API endpoint that is fronted by Amazon CloudFront. And it uses Amazon CloudFront to help, we can bring the API request closer to your customer. So the CDN POP is going to handle things like TLS. That's going to speed up the time that it makes for that request to the API gateway to be made. And so this is really meant for things like web apps, for mobile apps, potentially things like IoT-based devices that might need to talk to an API. And again, it's going to help really with the speed of that API call. We also support a concept called regional. Now, regional, very similar to Edge Optimized in that this is still a public API. However, this is an API endpoint where maybe you want to bring or configure your own CDN. Maybe you've got different CDN that you use. Maybe you don't need a CDN in front of yours. Maybe it's just being accessed by other services inside of an AWS region. And so the endpoint for this, again, lives in the public internet of an AWS region, as opposed to the edge with the Edge Optimized. And then lastly, we have a private endpoint. So this is for internal APIs for things like microservices or internal applications that would run inside of an Amazon VPC or virtual private cloud. For those of you not familiar with it, a VPC is the ability for you to basically carve out your own 4 digital walls inside of AWS, create your own networking space, gives you a lot of controls around subnets and NAT tables network ACLs, NACLs, route tables, security groups, and so forth. A little bit different of a concept. Again, not something we're going to get too in-depth on here today, but private API is definitely something that I'm sure many of you are building. Now, that's the different ways that we expose an API. How we expose an API, insofar as the protocols, is another. And so today we have 2 main protocols that we support and 3 models for this. The first that I'll talk about are HTTP endpoints. We have 2 of those today. Basically, the first V1 of Amazon API Gateway, which we call REST endpoints. That is technically an HTTP endpoint. And then the V2 product, which we launched last year at reInvent, that went GA a little earlier this year in 2020, is the HTTP endpoints. Both of them are used for, again, serving HTTP-based requests, which we see in all sorts of API use cases, traditional HTTP methods, GET, POST, things like that. And so today you can choose between the two of them. Deciding between the two of them right now today depends on a number of things. So there are a number of features that the HTTP APIs has that REST doesn't. HTTP APIs, though, is the future of this product, and so it is quickly gaining parity with a number of the things that REST has that we want to move over. We actually have all that in the documentation so that you can help evaluate which one is right for you. I'm actually today going to be showing an example that is based on REST APIs. That is largely just because it's what I've had running. But the benefit of HTTP APIs is much lower cost, much lower overhead, so lower latency, faster APIs. And again, a number of capabilities that we're building that's going to make it basically the future of this space. The other model that we have is WebSockets. And so WebSockets also increasingly popular these days, whether it be for things like near real-time interactive dashboards, chatbots, or I should say chat between people for communication, things like pushing data back and forth to IoT devices. There's a number of places where WebSockets can be really useful to you. Again, not going to go too in-depth on WebSockets today, but just know that it is a capability of Amazon API Gateway that you can make use of. Now, when it comes to authorization, we have a couple different options for you. And again, these are things that you can plug in depending on the API product that you're using. So with WebSockets, it works a little bit different. But in this case, just comparing the REST and HTTP APIs, what you see here on this table is the 4 different models that are supported across these 2 different HTTP endpoint types. So we have an IAM authorizer, which is supported in both. This allows you to use AWS's built-in identity and access management service. This allows you to create unique credentials that could be distributed out to the clients of your API. We have another model also shared by both, which is a Lambda authorizer. And so with the Lambda authorizer, you can basically have your API gateway execute a Lambda function on your behalf to do whatever the authentication or authorization model is that you might have. This could be talking to third parties. This could be an old user management system that you have. And then this can return back to the API gateway, again, that access or lack thereof. We also have in the REST API endpoints Cognito authorizers. So this is a direct integration with Cognito user pools. Cognito user pools allows you to do complete user management, everything from login pages to password resets to multi-factor, whole bunch of information you could capture, like a profile, if you will, about those users and store there. And so this is a service that's integrated, again, with things like AppSync, like Amplify Console, and again, provides a number of capabilities. And then we have a JWT, or I believe the term that the way to properly say it is a JOT authorizer. Now, this is an OAuth 2 compliant methodology, so you can plug in anything that is OAuth 2 compliant. You can do things such as using any service that has an OpenID Connect or OIDC compatible interface. And so this actually does support Cognito. So even though we say that the direct Cognito support is separate and only in the REST API, technically Cognito is a JWT compliant service as well. So you can still use Cognito with the newer HTTP API capability. So technically, probably should have a green star here, but just to be very specific in how the authorization options work, technically is 2 separate things. Now, again, when it comes to integration, there are a bunch of different things that you could put behind your API gateway. You could connect, for example, a Lambda function, which we're going to be demonstrating here today, which can happen via one of 2 different types of integrations, either a proxy or direct. We also support the ability for you to put API Gateway in front of any public endpoint on the internet. So whether it be HTTP or HTTPS, you can put API Gateway directly in front of it. So it can sit in front of a public load balancer, it can sit in front of a public EC2 instance, it can sit in front of a public load balancer that you're running in your on-premises data center. Any of that is possible with API Gateway. We have a capability called mock. This basically allows you to interface with various aspects of the API gateway without going to the back end, useful for testing and certain application workflows. We also give you the ability to put API gateway in front of pretty much almost any Amazon API that you might want to. Now, there are a number of ways and reasons that you might want to do this. You might want to expose a service like DynamoDB or Kinesis or S3 directly to your customers, but you may not want to actually do it directly to them. You might want to give them, say, a streamlined access to the API. You might want to give them certain capabilities. You might want to essentially hide those capabilities from them. And so with API Gateway, you can represent your own API that then maps back to those services. You can also do things like build essentially a CRUD interface in front of them. So we have many customers that will put API Gateway directly in front of DynamoDB such that they don't need that middle backend layer. They don't need Lambda. They don't need another, say, EC2-based backend to talk to DynamoDB. They can take those requests direct from the client to API Gateway and then onto DynamoDB. We've got some really cool resources about how to do that here as well that we will share for you here today. And then lastly, you can access resources that exist inside of an Amazon VPC or connected to an Amazon VPC, such as an on-premises resource via a VPN tunnel. This happens via a capability called VPC Link, and then resources that would have to be placed on the other side of a network load balancer, which in of itself brings a bunch of capabilities and options for you. So 5, again, major types of integrations possible really represents the full spectrum of anything that you might want to put out to your customers or to other services as an API. Now, we also have on the security side of things, AWS Web Application Firewall or AWS WAF integrated with API Gateway. If you have ever used another WAF product in the industry, if you're familiar with the space, AWS WAF works much like any other ones that you would see. So you can establish rules that can deny or allow traffic to specific APIs. You can block on things such as IP addresses or site ranges. You can run rules that look for common attacks. You can do geofencing. You can match for certain headers or certain terms, certain user agents. And so you can do this to basically lock down the access to your application and your API with WAF. Now, AWS WAF is built directly into API Gateway, so it makes it really easy to add this extra layer of security and, again, just be able to take care of your APIs that much better. Okay, so we've gone over some of the kind of high-level things about the capabilities of API Gateway, the kind of the front of it, the back of it, the side of it, a bunch of other things. Let's talk about how we can actually understand what's happening with API Gateway. Again, given all of the various things that are possible with it. So when we talk about, for example, monitoring, a common term that comes up is observability. And observability, much like serverless, can mean a lot of things to a lot of different people, but it often comes down to the understanding that knowing whether something is up or down isn't always just so binary. It's not always so kind of hot or cold, as it were, as to things are working. You can have small little failures. You can have performance degradations. You could be, having such a high latency that your customers are actually not finishing an action like a checkout or something like that. So we talk about observability. We're really looking to have a firmer understanding of, is my API or my application behaving as expected? What does expected mean in this case? Also, what is the usage? What is the business impact? And so these are all different ways or important things to think about when it comes to running an application these days. And I would say when people talk about observability, there's also an aspect around the organizational culture and practices, more so even than the tooling that's available to you. So being an organization that aggressively tries to collect data, that aggressively tries to trend data, that aggressively tries to understand, again, are things working the way that they should be? People will often talk about this concept of an observability pyramid, or the triangle of components here, which includes logs, metrics, and traces. You need to combine all 3 of those to firmly understand what's happening in a modern application, especially one that is a distributed application that might have several different components in different places that you might be talking from, one service to another. And again, these basically are the fact behind those 3 is to provide the full coverage of data, of information of what's happening inside of, again, a complex distributed system. So metrics should be numerical data measured at regular time intervals. And again, this is then stored as time series data or rate data and information that we typically see about the performance of an application. Log data is timestamped data that will typically contain different information about a specific action, event, request that's happened inside of a system, where you can use this for further debugging or further troubleshooting of the actions that have happened. And then finally, traces is really something that becomes much more important again in this distributed world, where a request isn't just going to a single application server and then coming back. It might be bouncing through a couple of different systems. And so the ability to trace a request through its full flow is incredibly important, especially if you want to piece together what's happening at each step along the way. So for us here at AWS, the two main services that make up kind of the observability capabilities mentioned here are Amazon CloudWatch and AWS X-Ray. And between the two of these, you get basically all of the capabilities that you should need to be able to troubleshoot, monitor, understand what's happening inside of your applications. Again, are things working out the way that they should? Is business as usual? Is my application performing, and so forth? So with CloudWatch, you get the ability to do things such as logs and metrics, alarms, events, dashboards, a couple other things that we'll talk about here today. And with AWS X-Ray, you get the ability to do traces and then analytics on that and draw something that's called a service map. Gives you kind of visual context for that distributed system. And we'll be talking about both of these here today as well. Now, when it comes to API Gateway, right out of the box, you get a bunch of great capabilities with CloudWatch. So you get a number of built-in metrics, things like 400 or 500 errors, cache hit or misses, the count of requests, latencies on the integration side, latency of request API Gateway. And this is just built in. You don't have to take action to get this data. What can you do with that data? You can graph it, you can trend it, you can alarm on it, all of the types of things that you would want to do. This is an example here of an application that we're going to go through where we see pretty kind of ho-hum standard thing here. I actually have, we'll be talking a little bit later here about CloudWatch Synthetics, has a canary that's pinging the site every couple of minutes. So we can see the latency of it remains pretty flat. The requests to it are pretty even. I don't see any errors here. I don't see any faults. I don't have any throttles. So pretty straightforward, but really easy to get this information without having to do a lot of work. On the logging side, so the second part of that triangle of observability, again, with Amazon CloudWatch logging, we have this directly built into API Gateway. So you don't really have to do a whole lot. You can configure and control some things, though, whereas, again, with metrics, a lot of that is just built in. So with logging in API Gateway, you control log level, so either error or info. You can also do full request or body logging if you want. The one thing you want to be careful of is that you are paying for the log data storage, so this could add up really quickly for a very active API. You can configure this really fine-grained, so per stage, per method, and override it in certain places. We also give you the ability to customize the access log format, a couple different formats, JSON, XML, the common log format. You can also choose what records are put into there. So if for some reason there was sensitive data that you needed to strip out, you could not log that. You also have the ability to choose where those logs go. So they can go to CloudWatch Logs, or they can go to Kinesis Firehose, which gives you the ability to then dump that data into S3, into Elasticsearch, to a couple other places. And the last thing, we'll touch upon this here in a little bit, there's a newer capability that just recently came out called Enhanced Observability Variables. This gives you the information in the request to the backend on a whole lot of information around what's going on with that request. And I'll show you here in a moment just what that level of detail is. It's really an incredible amount of detail now that you can figure out about what's happening in your API. And this could be great stuff to basically enable and be able to, again, troubleshoot or understand performance information and details in a whole lot of depth. Now, what you can do if you end up enabling the custom log format that's supported and you store it in a structured way, such as JSON, is that you can then use another part of CloudWatch Logs, which is called Insights. Insights is also a slightly newer capability, maybe just in the last year or so here, that allow you to be able to perform really detailed, kind of digging into what's happening with your system and with the logs that you've captured. Such as you can visualize it. You see here a little chart of where we see some errors over a period of time. We've limited it to a specific number of those. And we could see that around this kind of 147-ish minute mark that we had some errors, and we can then go through and figure out, okay, what's wrong with those, and again, use that to potentially troubleshoot what might be going wrong with our application. And so again, this is just built right into CloudWatch, and just by sending structured data to the CloudWatch, you get the ability to make use of logs insights. So let's dive into this demo that I have for you here today. This demo is going to use a printable application that I have that I think will help us highlight some of the capabilities of API Gateway. This is an application that we have called Caffeinate Me. What it does is it uses a map of here right now, pointing at New York City. And as I click around this map, it is going to show me various locations where there are coffee shops. Now, this isn't totally complete data. This was grabbed from an example file somewhere. But as I click around, I loosely get to see where there are these different coffee shops. Now, the way that this is working is as I click, it's actually sending to API Gateway as the request these latitude and longitude numbers that you see down at the bottom here. And then based on that, it gets passed to a Lambda function, which then is using a DynamoDB library to look up inside of the circle around this latitude and longitudinal point, again, the data points that represent coffee shops. So pretty straightforward. The front end is hosted in Amplify console. Again, the back end is API Gateway, Lambda, and DynamoDB. Now, if I come over to the AWS console, I can go and dive a little bit deeper into what's happening. So first, let me go to the API Gateway console, it's again the focus of today, and I'll find the API called Coffee Locator Backend. It's a really straightforward API. I basically just have a post, again, that gets that latitude and longitudinal coordinates. If I click in on here, I can see the information of the Lambda function that's configured for it. In terms of stages, I have a prod stage and a staging stage, and this is just because this was deployed using the SAM tool. Now, if I click into prod and I go into logs and tracing, I can see that I've got a bunch of information that has been pasted or that's been made available here. I have enabled all of the logging information at the info level, logging request and response data. I'm doing detailed CloudWatch metrics, basically turned on all of the capabilities, including X-ray, which we'll talk about here a little bit. So I'm going to get a bunch of information from this. Let me go back up here to services and go to CloudWatch. So if I come to CloudWatch and let's say I want to look just at log information, so I can come here to log groups, I can click on API Gateway Coffee Locator, and so I see a bunch of logging information from recent calls. I could say search all of these, and then can see all of the events here as they load up. So I see a bunch of events coming in. I see the IP that they're coming from, which is my IP. I see, again, a bunch of information that's come in through this. And so I can use this to dive deeper into the request. I also could potentially troubleshoot things around, for example, here I see the response length, I see the code, so right there. So a bunch of information that's made available to me from these logs. Now I can customize the XML, or sorry, the JSON file that is created here to take in different data. Now you'll notice here that I actually don't have the full body of the request. That is because of how I configure an API Gateway with the custom logging. Now, if I come back to the API Gateway console for this backend API, I can also go over to this dashboard that we have here. Now, this dashboard is going to be just showing me a number of some of the default metrics. Let me zoom in here on the last 24 hours. And so we can see here kind of where there's been a spike of traffic of things that are coming through on this. We can kind of go through and get various data. Now, if I click through on this, it's going to take me back to CloudWatch. And so what I can see here is a bunch of information. This is the count of requests over time. Now, I actually have a CloudWatch Synthetics Canary, which we'll talk about here in a moment, hitting this application once every 5 minutes and also hitting the API once every 5 minutes. So I'm not getting a ton of data. This is not a, let's say, highly used application, as it were. I can go, though, and change the data that is being graphed here. So this is the current data. I can come into API Gateway by API name and go and say add the latency. get some more information there. I can add 400 count, 500 count, the overall count of requests. And so this now could be much more useful for me to be able to get a bit more information into what's happening here. I thankfully don't really have, if we look at this, much in the way of errors. I see latency shot up for some reason there, but otherwise, this is all pretty much good stuff. So this is all good traffic. I don't really see anything in any of these charts for 4 and 500s. So again, this is the pretty much the basic straightforward stuff. Yes, I had turned on some additional logging. We see that structured JSON here. That could be then again dove a little bit deeper into using insights. But again, right out of the box here, I get a bunch of really basic capabilities in API Gateway to troubleshoot things. And so, again, that's going to help me out in some of those basic things up through the slightly more advanced. But again, it doesn't give me everything. It's just two of the parts of the observability triangle. So let's go and talk about some of the other capabilities that we have and some of the more advanced things that we can do. So I mentioned earlier that when it comes to being able to capture data for API Gateway, there are actually a number of places where information can be generated. If we look at what's possible in a given request, even before it hits the integration, and again, we get a number of bits of information from the integration, whether it be Lambda, whether it be, say, EC2 behind a load balancer that we can dive into, but just of what happens inside the API Gateway service, there's basically 4 major components that could possibly be part of a request process. So there is the AWS WAF, the authenticate, the authorizer, and the authorize steps. So WAF is only going to show up when you have enabled AWS WAF. Again, during this phase, rules are evaluated, and the request could be stopped or discontinued from being able to go on. If authenticate is only a request step that is possible when you are using Identity Access Management, or IAM, as the authorizer for your API Gateway. If you are using Lambda, the JWT, or Amazon Cognito authorizer, then you will see a authorizer step in the request. And then lastly, the authorize step is present when you use either Lambda or IAM as part of your authorizer. So 4 different possible phases here that can exist as part of a request. Again, depending on how you have configured your application. And so what we've heard from customers was that they wanted more visibility into the various aspects of this request cycle. They wanted to understand what information there was, what data there was, and so forth. And so we recently announced this new capability called Enhanced Observability Variables. This is data that is passed in, as you can see here, as part of the context that gets passed in a request down to the back end. And again, it covers the phase and then various information about it. And so what we can get here now is a whole bunch of new information about the process. So as, again, depending on what you've configured for an authorizer, depending on whether or not you have WAF, these context variables would exist. Now, what can you do with these? One, you can obviously log these and just put them into CloudWatch logs such that you can go and pull out various bits of information. You could use things like log pivots to be able to turn those then into metrics that you could then alarm against. And so again, it's giving you this further context for what's going on. There are a couple of other variables now that you can get down at the integration level as well. And so again, this is a new feature that just came out a couple weeks ago. And so you might have missed the announcement for it. If you did, you can actually go and read the blog post. And this is a short link here. So s12d.com/troubleshoot, a great blog post by my peer, Eric Johnson. So take a look at that. And again, this is enhanced observability variables. Now, coming back and talking about the third kind of part of the observability triangle, which is tracing. Now, for tracing, we have AWS X-Ray. So AWS X-Ray, unlike CloudWatch Metrics and CloudWatch Logs, is not something that is enabled by default. You do need to enable it for your application. X-Ray is built in today to a number of AWS products, so API Gateway, Lambda, step functions, a bunch of places. You can enable it also inside of EC2 and or inside of a container that you might be running an application in. And so it's going to give you a bunch of information on all sorts of things. So we see here this service map, so you definitely can get a view that shows the request flow through a distributed system. The ring here can represent a number of different things depending on how you're looking at the console. You can then also get a full trace, so you can see the results, or I should say the steps of what's happening inside of your application. This is an example of an X-ray trace for a Lambda function. We see some of the service team, the services initial kind of spin up here. Then we see it creating an S3 client, talking to S3. In this case, that little red exclamation down at the bottom there where we have a 404 code tells us that something went wrong on a put object call. And so we can continue then to dive deeper, looking at logs, looking at potentially other data that's captured here. Now, X-ray also comes with a number of other capabilities beyond this. So one capability we have is X-ray analytics. As the name might imply, it allows you to do a lot of diving deep into the data that X-ray can capture for you. So you see here, a histogram of the performance chart. You see how that is aligned through certain trace sets that have been created. You can do all sorts of filters on information that's been captured. And a lot of this is because one of the other things that you can do with X-ray is capture custom information. So you can capture all sorts of information by creating what's called a custom annotation or segment, and then be able to then take that data and dive a lot deeper on it. So again, there's some things that come just out of the box by default by turning on X-ray, and then there's this whole world of capability that you could have in your application code by tooling with the X-ray SDK. Now, we take this one step further with another capability in CloudWatch called Service Lens. Service Lens basically puts everything that we've been talking together in one place. It puts together logs, puts together metrics, and puts together traces. So essentially, it's a observability dashboard of what's happening inside of your application. And it gives you just a ton of data, as you'll see here in a moment. We could do things such as look at response time distribution based on the traces that we've captured. You could also go and see the same kind of X-ray waterfall with a whole bunch of information here on a per trace level, and then dive deeper into logs and into metrics, into other capabilities. So let's actually go back to the console and take a look at this here real quick. So I've already gone now in the CloudWatch console and loaded up the service map. I've actually then filtered it down by our API gateway, again, the coffee locator backend that we have here for the application today. And so what I see is clients make a request to the backend. The backend talks to Lambda. Now, this is just a small snippet here of all of the data that's possible. If I click back to full map, I see a whole bunch of information. As you can see here, there's a lot of stuff that's being captured. Now, I'll explain where a bunch of this comes from here in a moment. But if I come back into my API gateway, which is all the way down here at the bottom of this chart, I can actually see then that we talk to Lambda. And then from the Lambda service, we have my Lambda function. And then I can see that actually we also then talk to DynamoDB. So a table that we have behind the scenes for this application. I can zoom in here to make it a little bit easier to view. I can specifically highlight the specific node. So I can come down here and show the database node. And again, when I scroll down below here, I see a whole bunch of information. Now, I don't currently have what are called X-ray groups configured. That would make my life a little bit easier here in being able to group together certain resources. But let's say, again, going from this API, I could scroll down below here and see some basic information about latency and the number of requests and any faults that might have happened. And so it looks like at one point here, things did not work out well for me. But let's go to the dashboard for this. So this dashboard is giving me, again, a whole bunch of information specific to my API. So again, my API gateway stage, coffee locator backend prod. So I see things such as the latency, the P50 or the average, and then the P90, so the 90th percentile of it. I see the trace request count. I see how there were some errors a little while ago, and I could potentially dive a little deeper into that. I see what traffic was okay. And then again, other information, 400ths, throttles, and so forth. Scroll down here, a couple more of the service metrics that are available to me. But now let's say that I want to actually kind of dive in here a little deeper. Let's see if I can find what these failures were. So I can go in here and highlight these failures. Let's be really specific with these failures. And so I see that at one point, again, I got a whole bunch of failures that happened here with this API. So now that I have kind of zoomed in on this time, I can go say view traces. And this is going to pull in a bunch of information on the traces here. Now I see that I don't see the same errors that are shown here. Let me open up this time window here to the last 6 hours. All right, so now I can filter here by these faults. So I can add this trace status to the filter. So now it's going to trace based on faults. I can see that there were a certain number of traces that met this criteria. And then I can come down here, and as you see, I see all sorts of trace information. So this is a ton of stuff that I can use to dive deeper in here. I can click onto this trace ID. I see that there was an issue with API Gateway. And then I can kind of come down here and look and try to figure out why. So I see that there was a fault on the post. I see that we invoked Lambda, and then the Lambda service went and talked to the backend. And then at some point here, something did not go right. And I could come into this and try to understand the errors. So I can expand these logs. And so it looks here like I had an error with the lat and lod data, the latitude and longitude data that was passed in. Now, I actually do know what this is. This was me configuring the canary for this application. Again, something I'll talk about here in a moment. But basically, I've been able to pretty quickly determine where my fault is, where the problem was, and how how to potentially resolve it. Again, I get a whole bunch of information about this endpoint. I get the ability to see all of the log data for the logs that have been captured. So I see here, this is again for the Lambda function that is the back end of this. And it's giving me all of that good detail, all of the good information, again, that I might want to have about what happened here, what went wrong, and then hopefully leads me towards how to conclude, how to fix this. So that's really kind of the idea here behind Service Lens. Be able to get all of this information, be able to figure out how to dive into a problem, figure out what happened with it, and recover from that issue. So that's Service Lens, again, combination of traces, of log data, of metric data, glues together some of the various pieces of your distributed application. All right, so we've kind of gone through a bunch of things so far here today. We've talked about capabilities of API Gateway. We've talked about some of the observability capabilities that are built into API Gateway, shown you things like metrics and logs and how you can look at those. Also showing you Service Lens, which brings in the power of traces from X-Ray. The next thing I want to talk to you about, though, is one that I'm really, really excited, which is CloudWatch Synthetics. Now, CloudWatch Synthetics is another newer service that we have here at AWS, and it's one that, for me personally, I've been pretty excited about. So the idea behind Synthetics is that you create what's called a canary. Now, the canary is essentially, behind the scenes, a Lambda function that executes code that you write that can be used to test a web application, an API, really anything that exists out on the internet today. And so it's pretty straightforward to set up. It accesses the same endpoints as your customer. So you point this at production. And the idea here is that the canary should ideally be able to sniff out any sort of issues that you might have with your infrastructure. It should be able to tell you if latency is beyond a certain threshold. It can help you with doing error testing and alerting. And so canaries can become a really important part of being involved in your overall development workflow. It has really deep integration with logging and X-Ray, and so we'll see how this can help us out again in a couple different places. So once you create your canaries, they can run on a regular interval, so you can have them run every minute, you can have them run once a day. You can manually execute them, so you could hypothetically put this into, say, like a CI and CD workflow and test a bunch of them, you've got a number of options here that are available to you. So this is a screenshot from the console right here for my Coffee app. Again, you can see that I've got 2 configured canaries. I'm filtering for the 2 that are relevant for this. And yes, I realize that I have spelled Venti 2 different ways here. Don't worry about that. So again, Synthetics, really kind of powerful thing. Let's actually go and dive into the console and take a look at what you can do with this. So here I am, again, back in my console where I've got my canaries configured. Now I've got 2 different ones here. The first one is actually just crawling the web endpoint for this page. So it actually comes and shows the output of what the page looks like when it first loads. I see that over all of my canary runs, I have 100% availability. There's been no failures. But now I can actually dive a bit deeper here. So I can pull up this data here, what's called the HAR file. And the HAR file basically is a complete dump of a waterfall of everything that was loaded, or all the calls were made as part of this page. So had it been, say, a partial failure, I would have gotten information then about that. So this is all of the things that are included, all the places that I reference out to. I can see all of the information about those individual calls. This is all captured by the canary for me. Similarly, I can see the logs of the canary. So again, if there was a failure, I could dive deep into, potentially what had gotten wrong, what resource, what was the error code. And then also I can see the X-ray traces. Now I'll come back to this in a moment here with the API, but as you can imagine, what I could do with this if I did happen to see errors is that I would be able to go and dive deep into them back through the X-ray traces. So this is the web page itself. Now for monitoring, I get a bunch of metrics and information about how long the test takes to run. I see, potentially if there is something that ran slow for some reason. So this ran longer than I would have expected. I could, dive into this specific execution and try to figure out what happened here. Again, no errors. Everything seems good. And then I get some information about the Lambda function that runs. So it gives me, again, some of that basic information. Just let me know that it's not Lambda that failed or maybe had an issue. From a configuration standpoint, again, pretty straightforward. I basically pass into this what the URL is, and I'll show you what it looks like to create this here in a moment. But this is actually using what's called a built-in blueprint for the canaries. So let me go back to all the canaries here. Let me create a new canary, or just as an example. So I go into create canary, and what I find here are a bunch of options that we call blueprints. There's one called heartbeat monitoring. Again, this just loads a single URL, make sure the page is working. This is what I'm using for the Coffee app. I can monitor an API. I can do broken link checker. This allows me to use something called the Recorder plugin. Now, with the Recorder plugin, I can actually get a workflow of steps that I would want to execute on a web page. So I could enter text into a form, click submit, and kind of take a flow from there. Similarly, I could use a GUI workflow with actions to build through things. So there's a number of options here that are available to me for built-in things. I can also just go and edit a script. So the canaries support Node.js as a Lambda function runtime, and so I could go and just directly here in the editor, or I can import from S3. So if I've created my script elsewhere, I could do that. Now you can also manage these canaries via CloudFormation, and so you've got a couple different ways for being able to work with this. Now again, the heartbeat monitoring example, where again, it just basically goes and loads a single URL. This is really straightforward. I name my function. Oops, we can't have capital letters. And then I put a URL out here, and then it will go and ping that URL. And again, I see the code that's actually being executed, and it's just 30-ish or so lines of Node.js. Super simple, super straightforward. I can set the schedule. I can configure some additional information around a timeout, for example. I can set data retention, so how long do I want to keep the data about this? It stores that information in S3 for me. IAM permissions. Now, one thing that's optional here is the ability to create CloudWatch alarms. I haven't really talked too much about CloudWatch alarms here. The concept should be pretty straightforward, based on metrics thresholds, based on events that happen, or based on my canary failing, I could actually trigger an alarm to take an action. So there's a bunch of options that could happen as part of this. You can also run these canaries in a VPC. So if you had a private API, if you had a private web application that existed inside of a VPC, you can still use synthetic canaries to execute. Tagging, and then down here at the bottom is my ability to enable X-ray for this canary. So again, really straightforward here. Let me hop into the API example. Now the API example is also pretty similar. I did have some failures here earlier today. I can go and look at the logs and pull out where the failure was from my application. So it basically told me that there was a internal server error. So this was the response from my API gateway. And what I could do from this is dive deeper into the information related to this failure. So I see here there was a 502. I can go and click on this trace. I can scroll down through here and I can see that there was some sort of invocation error with my Lambda function that is on my backend. And so I could go from this trace into my Lambda function and attempt to figure out where that failure was for this time, for this execution, and then be able to dive into what it was. Now, if you remember earlier, I was showing failures in API Gateway. And where those failures came from was actually how I configured this canary. So when you configure this canary, I needed to pass in the data that would be used for my API. So as I mentioned earlier, when you launch and run the Coffee app, every time you click, it passes in the latitude and longitude. In this case, when I originally configured it, I did not properly escape the JSON inside of here. So that had caused those failures. But again, as we've seen now, for the last several hours, it has been completely successful. And it's really only if I go further back in today where I'll find those failures. All the way back to the beginning here. So pretty straightforward, again, pretty exciting stuff. It gives me all sorts of information about the performance of this. I get a bit of a confidence band for what's to be expected here. Again, there was one point where my app got really slow. I could dig into what happened with that. Maybe it was a cold start. Maybe there was something else happening. Again, the configuration for it, and then tags, which I don't happen to have any. Now, one of the other things that I can do here is I can jump into a service map view. And so if I click on View Service Map, this is going to take me, obviously, to the CloudWatch Service Map page. And what I'm going to see here is this canary and what is talking to it, what is coming off of it. It's a little hard to see here, given that I've got quite a few things going on. But let me pull here the canary itself out. So the canary for this has been talking to where is it here? My API endpoint down here, and then it talks to S3 and it talks to CloudWatch, and again it talks to S3 again. Those are the resources for it. But down here, I see the information about it. I can view the traces that have been created for it, and I can use these to determine if there has been any issues in my application. So I just clicked through a canary trace, and now I see the normal trace for my application. So I see my API gateway, I see the two Lambda segments, and then I see my DynamoDB table. And then from there, I'm able to do all the same troubleshooting I could do before. I can see the full flow of my call in my application. And again, I can see that this was a synthetic execution. So this came from CloudWatch Synthetics. So again, in short here, what I'm able to do with this is generate a test that generates a trace that if there is a failure, if there is an issue, I get logs, I get metrics, I could have alarms, I could have X-ray traces, I could have detailed information. What did I do? I went and just created a canary. Really simple, really straightforward, pretty powerful thing. So I think folks will find this to be fairly useful. Again, you can configure how it runs, when it runs, what you point it at. And so I would definitely encourage you to take a look at canaries. Awesome. So wrapping up, just to kind of summarize here, a troubleshooting workflow. Again, we didn't talk about alarms, but I think that's probably something that many AWS customers are familiar with, and you can read about, in the CloudWatch console or in the docs. You receive an alarm, you receive a page. What do? you look into Service Lens, identify where the failure came from, look into traces, figure out, is this just a single instance? Is this many instances? What do my trace data tell me? Dive potentially into X-ray analytics. Didn't go deep into X-ray analytics here today, but that could provide us even more fine-grained views into the workflow that X-ray captures. And then finally, be able to use logs and metrics to diagnose what happened. And so with this, we're given, again, a ton of tools at our fingertips to be able to troubleshoot and to be able to test and then get the results of those tests for our application. Okay, so in closing, we've talked about a whole bunch of stuff here today. We've covered, again, some core functionality for API Gateway, talked about some of the built-in capabilities of logging and metrics, some of the optional things you can do with logs, the ability to use things like CloudWatch Logs Insights, which is super powerful capability for digging into log information. Talked about how you can easily enable X-ray, and then once X-ray is enabled, it gives you a full wealth of information. And then you can combine all this together with Service Lens, and with Service Lens, you get, again, metrics, logs, traces, all put together for you, ton of correlation of that information in, effectively a single pane of glass. And lastly, you can use synthetic canaries to continuously test your APIs, be able to know if they're functioning, know if your web pages are loading right, test for things like broken links. And again, this is all from the same console page. So a lot of capabilities here, a lot of things that you can do. We're just kind of scraping the surface here today, just because there is really so much depth to these topics. With that, I would encourage you to check out serverlessland.com. This is a site that my team has built where we are aggregating all of the serverless content at AWS into one place. We're hoping soon to add community contributions, stuff from our AWS heroes, community builders, stuff from AWS partners. So work in progress, early days, but please get a chance to check this out here. Again, serverlessland.com. And again, my name is Chris Munz. I appreciate you joining us here today. You can find me at Munz at Amazon.com or at Chris Munz on Twitter. I'm going to try to answer a couple more questions here if we have some time, but I want to thank you for joining us and hope to see you at another Tech Talk soon. Take care.